Welcome to section 4. In this section, you're going to learn about functions in JavaScript. When we create a function, we're creating a little program in our program. We can execute that little sub-program as many times as we like. So let's explore why that might be useful. Remember when we created that temperature converter in the last section? We had a temperature starting off in Fahrenheit and we converted it to its counterpart in Celsius and Kelvin. Now that was just a single temperature. Imagine we were given a data set with all of the average temperatures for last year, so 365 temperatures. How would we go about converting all of those from one format to another? Well, we would actually need to write out that code, the conversion code, 365 times, one time for each piece of data we want to convert. When we create a function, though, we can create a little sub-program that handles that conversion for us. So we create this function a single time, and we call it, execute it, as many times as we need to. That's going to allow us to create reusable code, and it's also going to allow us to do some awesome stuff with JavaScript in the browser. For example, if I want to do something when someone clicks a button on the screen, I have to create this little function, this little sub-program that defines what exactly I'd like to do. So functions are essential for modern JavaScript. We're going to be using them throughout the entire course in almost every single video. So let's go ahead and jump right in and see what functions are all about. All right, let's start learning about functions. Before we do, we're going to create a new folder where we can put all of our function-related files, as the basics directory is getting a little crowded. I'm actually going to switch the folder that I have open in the Visual Studio Code editor. I'm going to open from the desktop my JS Bootcamp folder directly. Then, alongside of basics, I'm going to make a new directory, and I'm going to call this one functions. And in here, we're going to create our very first file, and we can just call this one functions101.js. Excellent. Let's also go ahead and switch the directory we're running our commands from. I'm going to use cd ... to go up a folder into the JS Bootcamp directory, then /functions to end up in the functions folder. And then I'll just use clear to clear the terminal output. So, as I mentioned in the intro, functions are little sub-programs. It's a little bit of code we can run over and over again. And there are three important parts to a function. Right here we have the function, we have the function input, we have the actual code to run. So what are we trying to do? Are we trying to convert a temperature, fetch a user, print a message? And we have the output. We're going to ignore the input and the output for the moment, and we're just going to focus on creating our first function, a function that runs some code. We're going to do that right down below. We're going to use let like we would if we were to make a string, number, or Boolean. Let greet user, that's what I'm going to call this function, and I'm going to set it equal to, and this is where we have to use the function syntax. So much like the if statement, there is a specific set of rules around defining a function. We have to follow those. The first one is to use the function keyword. We literally type out function. The next is to open and close a set of parentheses. We're going to talk about what goes in here later. For now, though, it's perfectly fine to leave it empty. And then we are going to open and close a set of curly braces and hit enter. And there we have it, our very first function. Does it do anything? No, but it is indeed valid. So much like our if statements have a code block where we can put the code we want to run, like for example, right inside of here, our functions also have a code block that creates its own scope right here. Anything we want to do when the function executes goes right inside of here. For the moment, we're just going to go ahead and use log to print a message. Later on, we'll figure out how to convert a temperature, combine variables, call other functions, or do whatever else we need to do. In here, what are we going to do? We are just going to print a little message to the screen. Welcome, user. Excellent. Now that our function actually does something, we can't run the file just yet. Well, we could run the file, but the function's never going to execute. At this point, we've defined a function. Defining a function would be like defining a JavaScript file. Yes, it exists, but you haven't actually done anything with it. If we want this code to run, when we execute this file, we have to call it. So if I were to execute the script, node functions101.js, what do I get? I don't get an error, I just get nothing. The program didn't run. If I do want to run this little subprogram, I have to call the function. Right here, I execute it by referencing it by name, so greet user. This alone isn't enough. I have to use the function call syntax, which is an opening and closing parenthesis after the name. Now, we'll talk about what goes inside of here a bit later too. For now, it's perfectly fine to leave it empty. If we save the file and rerun things, what do we get? We get welcome user printing to the screen, which is fantastic. We have created and called our very first function, and we can call this function as many times as we see fit in our program. So I could paste that line 2 more times, and what's going to happen if I run the script? I'm going to see our welcome user message 3 times, and that's exactly what I get. With the most basic function accomplished, let's go ahead and create something a little more practical. We are going to introduce the input, the code, which we already have, and the output. For this one, let's say we want to square a number. So what do we take into the function? We take in the number we want to square. What does the code do? The code squares the number. What's the output? The output would be the squared number. So if I passed in 3, the code would multiply 3 times 3, and the output would be 9. Let's go ahead and see that in practice down below. I'm going to use let to create square. I'm going to set it equal to a function, so we use the function keyword. We open and close our parentheses, and we open and close our code block using curly braces. Down below, we can also go ahead and call this before filling it out. Square, and I'm going to pass in a number. Now, how do we pass a number into a function? Well, we do this by providing what's known as an argument. So the input, in terms of how the vocab works for JavaScript, it's actually known as an argument or arguments plural. So if you read a blog post on a function, you're not going to see input thrown around. You're going to see argument. So if we want to pass an argument into square, the value to square, how do we do that? Well, we provide it right here between the parentheses. So if I wanted to provide a number, I could literally just put a number right here. I could say 3, for example, or I could reference a variable that stores the number. So I could have a variable up above, let num equal 3, and then I could reference that variable instead of just putting 3 right in there. Both of those have the exact same effect, and for simplicity's sake, I'm just going to stick with passing in 3 right there. Let's go ahead and delete this line completely, and we're back to where we started. So at this point, we are passing in a single argument to square. We're passing in the number 3. The question is, how do we actually get access to this value inside of the function code? Well, we do that by naming the value right here in the parentheses for the function definition. So much like we would name a variable, we go ahead and name the argument right here. We can call this one num. Let's go ahead and actually do something with num to make sure the value is getting passed in correctly. Right here, console.log, I'm just going to print out num. We'll focus on squaring the number in just a second. If I save the file and rerun it, I would expect to see welcome user 3 times, and then I would expect to see 3 a single time. Let's go ahead and rerun the file, and that is exactly what we get. Right here, the argument value is getting passed in. We are seeing 3 get passed into the function, and when we print it, what are we getting? We're getting the value. We are getting 3. Now we can add multiple calls to square as well. I could call square right here with 10 if I wanted to, and now if we rerun the script, the first time the function runs, the value will be 3, and the second time the function runs, the value will be 10. Over here, we get 3, we get 10. So this is how we can set up basic input. We'll learn more about passing in multiple values later and what to do if a value isn't passed in. For now, we're going to stick with a more trivial setup. So what do we do from here? We square the number. We focus on the code side of things. We can do that right here. Let, I'm going to call this one result equal, and all I'm going to do is take the number and multiply it by, using the asterisk sign, what? The number. So num times num. Now we have this result. So in the case of 3, it would be 3 times 3, which would be 9. In the case of 10, it would be 100, 10 times 10. So we have the input, our arguments. We have the code that actually does something. The last piece is the output. And the output is also known as the return value. So just like if you read an article on functions, you won't see input, you'll see arguments. You're not going to really see anyone call the function return value the output, but that is an easy way to think about the three pieces. It's really called the return value, and that's because to return something, we have to use the return statement. So right here, how do we do that? Well, we type out return. This is a reserved keyword in the language, and it can be used a single time only in your functions. So right here, we can choose to return a single value from this function. What's that value going to be? It's going to be result. So we reference it, result right here. Now we have a function that does all three things. It takes in some value as the argument, it uses some code to do something meaningful, and then it returns a value. In this case, it returns the squared value. Now, if we were to run the program in its current state, it wouldn't do anything. We wouldn't see any output related to our second function. Right here, we get 3 instances of welcome user, but we don't get 9 or 100 printing. That's because the return value isn't being used. So let's figure out how to use it, and then we'll move on to a challenge where you'll need to create a function of your own. What I'm going to do right here on line 16 is create a variable. So let value equal, and then on the right hand side, as the thing to store in value, I'm going to keep the function call. So this is the setup we use to call a function with an argument and then store the return value. So the end result of this is the return value, and here we're just putting it in a variable. We can do the same thing down below for square 10. Let's go ahead and actually do that. Right here, let other value equal, and then what are we going to do? Well, we're going to get the value back from calling square with the number 10. The end result, 100. Now we can actually print both of these to the screen, console.log value. And you'll notice something, log is indeed a function. We're calling it with some parentheses, and we're passing in an argument. Whatever argument we pass in gets printed to the console. So now we know a little bit about this line. We still don't know what the dot part is and the console up in front, but we can at least break down this piece right here. On the next line, console.log, other value. Then all we're going to do is save the program and see what happens when we run it. I'm going to rerun the script, and this time around we are getting welcome user 3 times. We're then getting the number 9, which is the correct result, and the number 100, also correct. So there we have it. We have a function that has a set of arguments, a number. We got our code, we have our output. When we want to call a function, we reference it by name with some parentheses on the end. In there, we can pass in the input we want to provide to the function. And if we want to do something with the return value, we can just put the function call over here with a variable set up beforehand. Now that we've seen all of this in practice, I want you to create a function on your own as the challenge for this video. So down below, a little challenge area is indeed appropriate. For this challenge, you're going to be creating a function called convert Fahrenheit to Celsius. And as the name suggests, this function is going to take in as the argument the temperature in Fahrenheit. It's then going to run the conversion algorithm, and it's going to return the temperature in Celsius. So after you create the function, you're going to call it. Down below, call a couple of times. And if you want some sample values, 32 should get converted to 0. And then another good one would be 68 degrees Fahrenheit, which should get converted to 20 degrees Celsius. Then the last thing you're going to do is print the converted values. So this is very similar to what we just did above. We defined our function. We then called the function a couple of times, and then we did something with the return value. That's exactly what you're going to be doing down below. Define the function, call it, do something with the returned value. If you forget how to convert the temperature, don't worry. You can just use the temp conversion project that you created before. You have the algorithm sitting right up top. If you don't have that file anymore, you can always download it. It's available in the lecture zip for every single lecture. All right, take some time to knock this one out and then go ahead and test your work. When you run the program, you should see 0 and 20 at the bottom, assuming you're using the same 2 input values I set up right here. Pause the video, and when you're done, click play. How'd that go? Hopefully you were able to get that done without too much trouble. I'm going to kick things off by defining the function up above. I already have the variable name typed out, so I'm just going to remove the 2 slashes and toss let up front. I'm then going to set this equal to a new function. Got my function keyword, my arguments list, and the code to run. Now there is going to be a single argument for this one. The name you picked isn't particularly important as long as it's meaningful. So maybe you went with temp. I'm going to go ahead and go with Fahrenheit. Next up, we need to actually do the conversion process. I have to get the value in Celsius. We already have that code sitting right over here, so I can actually just take that algorithm, copy it, and paste it right in here. Now, it's important to remember, this algorithm references some variables like Fahrenheit, but that's okay because we have Fahrenheit defined up above. So we actually don't need to change anything about this line. What's the next thing we want this function to do? We want it to return the converted value. So down below, we can wrap up our function by using return. What are we trying to return? We're trying to return the temperature in Celsius. Now we can move on to the second stage, which is to actually call this a couple of times. So right here, let temp1 equal, and we can go ahead and use our function convert, and you can see that the auto completion is actually picking up on the function that we created. And right here, we can just click that to auto complete it, and then we can pass in the value. I'm going to pass in 32 degrees for the first one. Let's go ahead and duplicate this line. I'm going to go ahead and highlight the whole thing, copy it, and paste it down below. And now what we're going to do is define temp2 for the second call, and we'll change the value. Let's go ahead and change it over to the other sample data I gave you. That was 68. The last thing to do is to print those 2 values. So console.log temp1, and down below that, console.log passing in temp2. With this in place, we can remove those comments and we can go ahead and test our work. Let's cross our fingers and hope everything works as expected. Right here, I'm going to rerun the script, and the only 2 values we care about are the last 2 values, the logs that come from the challenge. Right here, we're getting 0 for the first one, which is correct, and 20 for the second one, also looking good. So there we have it. This was a quick rundown on the basics of functions. Now at this point, you probably still have a ton of questions. For example, can I pass in multiple values? What happens if I call a function and don't pass in the arguments it expects? We're going to get to all of that in this section. At this point, what I wanted to explore is the basic syntax. The fact that when we create a function, we have our arguments, the code, and our return value. We've seen that in a couple of different situations. Let's continue on to the next video and start exploring some of the details. I'm excited to get to that. I'll see you then. In this video, you're going to learn about 2 new types in JavaScript that are going to allow us to segue into more advanced function techniques. These 2 types are undefined and null. Both of these represent a sort of absence of a value. So let's go ahead and kick things off by creating a new file where we can mess around with both of these. And we'll start with undefined. We're going to call this file undefined-null.js. And we're going to kick things off with an example we've seen countless times. We make a variable, let name, and we assign it a value. I'll assign this one the string gen. Then I print it, console.log, calling the log function, passing in the name variable. What happens when I run this? I'm going to get gen. We know that for a fact. We've seen this example before. Node undefined-null.js, and I get gen. This is not what's interesting. What's more interesting, and why we're having this discussion now, is what happens when we create a variable and don't assign it a value. So let's go ahead and look at this line right here. This line is 4 pieces. We use the let keyword, we name our variable, we use the equal sign, and we give our variable a value. But these 2 pieces are actually completely optional, which means that this right here is perfectly valid JavaScript. We are declaring a variable name without assigning it a value. Now, what's going to happen when this program runs? Well, we know that if we weren't declaring name like this, the program would fail. We would get an error trying to access a variable that's never been declared. In this case, though, we have declared it, we just haven't assigned it a value. Well, to figure out what happens, as always, the best way is to run the script. So I'm going to run the script, And what do? We get the word undefined printing to the terminal. So undefined is used in JavaScript to represent the absence of a value. It's set implicitly behind the scenes. So at no point in this program have I ever typed the word undefined. By creating a variable and not assigning it a value, JavaScript has assigned it the value of undefined for us. Now this is pretty useful because we can actually create an if statement, for example, and check if a given variable has ever been assigned a value. Right here, we can set up an if statement. If some condition, some code to run, and then we're also going to add an else clause right on the end. Now what's the condition? We're going to see if name is undefined. Is the name variable equal to, using the equality operator, and to actually create undefined, we just type out that keyword, undefined. It's a reserved keyword in the language. Right here, what do we have? We now have an if statement where we can do one thing if name was never given a value, and another thing if it was given a value. Up above, console.log. Right here, please provide a name. And down below in the else clause, we can just print the name because we know if this code runs, that name is indeed provided. Let's go ahead and run the script with name set to undefined. If I rerun it, I get my little message, please provide a name. So our equality check did indeed pass. This was true. Now we can assign it a value either on line 1 or down below, name equals Jen, for example. This time around, I would expect the second case to run. Over here, if I do go ahead and run things, that is exactly what I get. I get Jen printing because the else clause ran. Name was not undefined. Name was actually the string Jen. This is just one place where we're going to see undefined implicitly set for us. So let me leave a little comment up above. Undefined for variable. The other place where we're going to see undefined set for us is with our function arguments. So right here, undefined for function arguments, and we're going to explore that with an example as well. Right here, and let's go ahead and make a function like the square function we created previously. We're going to let it equal a function. We'll set up a single argument num, and then we're just going to fake the interior of the function. I'm just going to use console.log, and I'm going to go ahead and actually just print the num value to the screen. Down below, what we're going to do is call square. Now, if we were to call square with 3, we know that 3 would show up. We can run the script to prove it right here, 3. But if we weren't going to provide a value, what would happen? Well, what's actually going to happen is that JavaScript is going to set num equal to undefined. It's not going to crash the program. It's not going to say, hey, this argument is required. There's no way to do that. When an argument isn't provided, but it's named in the function definition, undefined is assigned as its value. Now we can save the program in its new state, rerun the script, and this time around you can see we're getting undefined. So that's the second situation. We're going to see it for variables that are never assigned a value. We're going to see it for function arguments that aren't provided. And there's one more notable situation I want to point out. This has to do with function return values. You know how when we return something from a function, we can store its value in a variable using this syntax? Let's do that right now. Right here, let result equal whatever is the return value from square. Then we will console.log result to the screen. So what's the return value from square? Well, we haven't used return anywhere in this function. So what's the return value going to be? Well, based off of where this video has been going so far, you can probably take a pretty good guess that it's going to be undefined. And if that was your guess, you would be correct. Over in the terminal, if we run this program, we see we get undefined twice. The first one is coming from right here, and the second one is coming from right here. So this is the third situation where we're going to see undefined. We're going to see undefined if we try to do something with the return value from a function, but that function doesn't actually return anything. If I were to return something, we would get that value instead. If nothing is returned, that is going to be assigned undefined. So those are the three most common situations that we're going to see undefined implicitly set behind the scenes. There are others, and we'll explore those as we explore more features of the language. Down below, we're going to wrap up this video with just one more example. Actually, let me go ahead and leave a quick note about that last case. Undefined as the function return default value. Perfect. So those are the three cases. We're going to wrap this video up with just one more simple example. Down below, I'm going to create a comment, but I'm not going to type anything in just yet. And what we're going to do is create a variable age and give it a value right away. So I'm going to define it and assign it the value of 27. Then I'm going to print it, console.log age. We're not going to rerun the program. We know what's going to happen. We're going to see 27 print. The question is, what if in our program we want to clear this value? Let's say the user resets the form in the browser and they want to start over. How do we clear a variable's value? Well, we can explicitly assign a variable the value of undefined. And we do that by setting the variable age equal to the value undefined. We type out the undefined keyword. And now if we were to rerun the program, which I will do, we will see undefined print instead of 27. I'm going to clear the terminal output by typing clear. Whoops, a little rendering glitch there. And what we're going to do is rerun the script. So let's use the up arrow key twice to get back to the script. And right here we see the last log is printing undefined, which lines up with this right here. The problem with this code is that I'm not sure if age is undefined because it was never given a value, like in the three situations we explored above, or if it's undefined because it was explicitly cleared by the developer. I lose that context between the actual JavaScript language assigning it a value and us explicitly assigning it a value. And this context can be important. So to preserve that, JavaScript gave us access to a different type that also represents a sort of emptiness, and this is null. Null is meant to be assigned like we're doing here. So we can set age equal to, instead of undefined, we set it equal to null. Now, when we run this program, we're going to see null print instead of undefined. I can rerun the script, and that is exactly what we get. So when we see undefined, we know it's a language default. When we see null, we know something was explicitly cleared by the developer of the program. Up above, we can make a note right here, null as assigned value. Excellent. Now that we know a bit about undefined and null, we're going to be able to move on to the next section and talk about more advanced function features, like passing in multiple arguments and setting default arguments if the argument value isn't provided. That is all coming up in the next one, along with more challenges and programming projects. I'm very excited to get to it. Let's jump right in. In this video, we're going to continue to explore functions by talking about how we can create functions with multiple arguments and how we can set default values for arguments that aren't actually provided when the function is called. To do this, we're going to create a brand new file in the functions directory. Let's go ahead and call this one something like arguments.js. And then we're going to go ahead and mess around with three examples. The first two exploring the features, and the last one a challenge for you. We're going to kick things off by creating a function that takes multiple arguments. It is going to take in multiple numbers, add them all together, and return the sum. So if we were going to set that up, we could use let to create add and set it equal to right here. What are we going to set it equal to? A function. And that function is going to take multiple arguments, but for the moment, we'll just put nothing inside of parentheses. Now, if we were to call add and do something with the result, it might look a bit like this. Let result equal a call to add, and then we can do something with the result, like print it, console.log result. Now, this is just a little template for how things might look, but it doesn't actually return anything, so result is going to print undefined, which is what we learned about in the last video. Now let's actually set up the arguments and function body for add. If we wanted a single argument for add, what would we do? We would just name it right here. If I was going to call it a, for example, I would set up a, and then I could use a down below, assuming it was actually passed in. So for example, I could pass in the value 10. Now, if I want to pass in multiple arguments, how do I set up the definition right here? All I do is I separate their names by a comma. So comma, And people usually add a space for formatting purposes. And then right here, I can pick what I want to call the second argument that's provided. So for example, I could call it B, and then I could pass in a second value by separating it by a comma. So right here, 10 for the first value, and let's use 1 for the second. So with this call signature, we're going to have A equal 10 and B equal 1. So if I were to add them up and return the value, I would expect 11 to come back. Now we could go ahead and create a variable where we add the two numbers together and then return that variable, but you can actually just provide the expression right in line. So I can return A plus B. This is going to add A and B together, resulting in 11. It's then going to return it, and if we run our script, we should actually see the sum printing. Let's go ahead and save the file and check out what happens. Over here in the terminal, I'm going to run it node arguments.js. When I do, I see 11 printing, which is exactly what we were hoping for. So if we want to provide multiple arguments, we just create a comma-separated list, both in the function definition and in the call signature, where we actually pass values in to the function. Now we could go further. There's no reason to stop at 2. You can have as many arguments as your function needs. So let's say we needed a third one, comma, with a C afterwards, and then we could provide a third value. For example, I could provide 5. Now I would expect the sum to be 16, assuming I actually use C right here. So A plus B plus C, the result should be 16, and if I rerun the script using the up arrow and enter, that is exactly what we get. Now there's really not a whole lot to it. You can add as many arguments as you want. You can have a function with no arguments, and there's no rule for when to use which. It's really going to depend on what the function needs. So if we're creating a function that calculates your income tax, we're going to need certain values. We might need one argument, for example, the amount of income you actually made. Other functions will need more arguments. Other functions will need less. So we've explored how we can set up multiple arguments. Now what I want to do is figure out how we can provide a default value if an argument isn't actually provided when the function is called. Let's go ahead and explore this with a second example down below. Right here, default arguments, and up above at the very top of the file, I'm just going to leave a little comment about this example. Here we explored multiple arguments. Awesome. So how do we use default arguments? Let's explore with an example. Let's imagine we're creating a multiplayer video game and there's a leaderboard, right? So all of the players ranked from the people with the most points to the least. Now there's two pieces of information that we're going to need in order to generate the individual row. We're going to need the user's name and their score. Now, not everyone's going to have a score. If you haven't played a game yet, we're going to come up with a good default value. We'll use 0. And not everyone is going to provide a name. Maybe you want to remain anonymous, so we're going to come up with a default name as well. Let's explore what this might look like. We're still going to be making a function. I'm going to call this one getScoreText. So this would just be one part of our video game. And I'm going to set it equal to a function. And this function is going to take two arguments: the name of the player and the player's score. Then, down below in the function body, we're going to go ahead and actually use these two values to generate a string. Before we do though, let's just use console.log to print out name. Then on the next line, console.log to print out score. And what we're going to do is call the function down below. I'm going to call getScoreText, and I'm going to provide no values. So I'm going to call it just like this. Based off of what we learned in the last video, I know that name and score will both be undefined. And if I rerun the file, I would expect to see undefined twice. I'm going to rerun things over inside of the terminal, and what do I get? I get 16 from the first example and undefined twice from the second example. So by default, if we do not provide an argument value, nothing is going to show up. But we can actually set up defaults, and we do that right here in our function definition. So when I define that the second argument should be called score, I can also provide a default value for that. So if it isn't provided, use this. In this case, we can set it equal to the number 0. How do we do that? Well, after the argument name, we use space equals space, and we give it a value. So the value could be a string, a Boolean, anything in JavaScript. In our case, it makes sense to use a number since we're talking about a score. So I'm going to type 0 right in here. Now we could say that score has a default value. If we change nothing about our function call and rerun the program, we're no longer going to see undefined. We're actually going to see 0. So what happens here? The function executes. It says, all right, call that second one score. There is no value, so use the default, and that is what prints. Now, should we provide a value in the call, it would be used. So for example, if I set the name equal to Andrew as the first argument and the score equal to 100, 100 is going to get used instead of 0. This value only gets used if there is no provided argument value. So in this case, I would expect to see Andrew and 100. And that's exactly what I get. We overrode the default value because we actually provided one. Now we could do the same thing for the first argument as well. I could set a default value for this. So after the argument name, space equals space. And in this case, we're going to provide a string value as the default value. So I can open and close some strings using single quotes, and right inside I can provide that value. And I'm going to call players with no name anonymous. Excellent. Now we have default values for both, and this makes the function a little more robust. We could provide no values, we could provide all of them, or we could provide some combination in between. So let's go ahead and delete all of the values we pass into the function and just make sure our other default is working. Right here, I rerun things, I get anonymous, and I get 0. With the defaults in place, we can actually work on making our function do something meaningful with these two pieces of information. So in the end of the day, getScoreText is going to return the score text, and I'm going to assign it to a variable. Let scoreText equal whatever comes back from calling getScoreText, then I'll print it console.log scoreText. Now all we need to do is to actually return a string from this function as opposed to just seeing what the argument values are. So I'm going to delete those console.log calls. Right here, we can return a new string. So for this one, this is going to be the individual line in our leaderboard. I'll start off with name, :space, and then I'm going to concatenate on the name, whether it's the default value anonymous or a value actually provided when the function was called. Right here, though, either way, we get access to that via name. So that's the first part. And the second part, I'm going to concatenate on a space, then score : space, and then their score. So right here, plus score. Now we're going to get a useful string back, and when we call the function and print it, we should see our little string with the values provided. In this case, default values for both, since none are passed in to the function call. I'm going to rerun things from the terminal, and right here we get just that. Name anonymous, score 0. We could actually put another little hyphen maybe right in between to make things a little easier to read. Awesome. Now let's go ahead and provide values. So I am going to provide a name, Andrew, and we'll say that I haven't played a game yet. So I'll leave score out of the function call. That means the default value is going to be used, and if I save the file and rerun it, I get name Andrew and I get score 0. We could also do the opposite. I could say there is no name, but they do have a score. Now, if I want to provide the second argument, but I don't want to provide the first, what I have to do is use undefined right here. So undefined, comma, followed by that second value. Let's go ahead and say I have a score of 99. Now I would get name anonymous and score 99. So we can provide no value for other arguments. We just use undefined right there. And remember, the only reason I'm doing this is because I want to get access to the second argument and actually assign a value. So I do have to provide something for the first one. If I left things like this, whoops, like this, what would happen? I would have 99 for the name. By providing undefined, I make sure that 99 gets set as the score. Perfect. Now it's challenge time. Down below, let's create a little challenge area. And what you're going to do is create a new function that has multiple arguments and uses the default arguments we just explored. This little function is going to be a tip calculator. So you could call the function something like getTip. Let's imagine that we go to a restaurant and we spend $100 and we want to tip 20%. What is that number? That would be a $20 tip. We're going to create a little function that figures that out for you. So right here, the function is going to take two arguments. It is going to take the total for the bill, and it's going to take the percentage you want to tip. You could call this like tip percent, for example. Now for the total, it doesn't really make sense to have a default. Each bill is going to be different depending on what you ordered, but for the tip, we could go ahead and come up with a default tip percentage. We could say 20%, for example, and we're going to reflect this as a decimal point. So 0.5 would be a 50% tip, 0.1 would be a 10% tip, or 0.2 for a 20% tip. We take the total 100, we multiply it by 0.2, that is going to result in 20, which is the correct tip value. All you're going to do is run that calculation, return the value, and that's going to be it for the function. So two arguments, a default for one of them. Then I want you to go ahead and actually use it. Call the function a couple of times with different values for the total and the tip. Make sure that the default tip percent shows up, and make sure that if you provide a different one like 0.3, that actually gets used. Take as much time as you need to create this function and mess around with it. If you get stuck, try to work through your problem, and then we're going to come back and go through things together. Pause the video, and when you're done, click play. All right, how'd that one go? I'm going to kick things off by creating my function, and I'm going to do that right here. Let get tip equal a function. This function is going to have two arguments. We'll provide those in just a second. Right here, the first one is going to be the total for the bill. Once again, no default for this one. Each one is going to be different. The second one is going to be the tip percent. And it's okay if you called these things something else. That's not the important part. The important part is the actual function setup itself. Now for the tip percent, we are going to come up with a default value. I'm going to set it equal to 0.2. So by default, you can just provide the total and we will calculate the tip based off of that 20% number. Inside of here, what do we need to do? We just need to multiply the two values together and return the result. So I can return total times tip percent. Perfect. Now down below, we can actually use that function. So right here, I am going to let tip equal, and then I'm going to call get tip. And I'm going to pass in a total, let's say 100, using that example I came up with before. And for this one, I'm not going to provide a tip percent value, so it should use the default 0.2. Right here, console.log tip. I'm going to remove the comment, and then I'm going to actually run the file. Let's save things and execute them. I'm going to use clear to clear the terminal output, and the up arrow key twice to rerun the arguments file. Right here, what do I get for the tip? I get 20, which is indeed correct. Now let's override that and provide a different tip percent. I'm going to provide 0.25, a 25% tip. And now if I rerun things, what do I get? Right here, I get $25. And if I were to change the input value, setting it to something like 40, I would get 25% of 40, which would be $10. And if I rerun it, that's exactly what we get. So real-world functions aren't just going to have a single argument like we saw in the past. Real-world functions are going to take multiple arguments. There are certain values like total that we're going to require. There are others like tip percent where it does make sense to have a default value. And you're going to get a lot of experience with this as we actually use functions in the projects we create. Now that we know this, though, we are ready to continue learning about functions, and we're going to do just that in the next video. Stay tuned. I'll see you then. In this video, I want to talk about scope in JavaScript as it relates to functions. Now, you've already explored scope as it relates to if statements. We messed around with that in the basics directory. Here we have scope.js. We learned that in JavaScript, we have a lexical scoping. We have a single global scope with multiple local scopes. And we learned that one way to create a new local scope is via the if statement. So variables defined in the if statement are only accessible in there. They're not accessible outside of there. And we explored how we can create a little visualization of just this. Now we're going to take the same rules and apply them to functions. So what I want to do is just create a new file in the functions directory. I'm going to call this one function-scope.js. And what we're going to do is copy and paste a function that we've already created. In Functions 101, we created convert Fahrenheit to Celsius for the challenge. Now your name might be slightly different since it was a challenge. I'm going to go ahead though and take all of the code down here, copy it to the clipboard, and paste it into function scope, and we'll use this to explore how scope works with functions in JavaScript. So let's go ahead and create a little scope tree to visualize the scope we have for this file. First up, we got our global scope, which we always have, global scope, and we have a few different things in the global scope. I have convert Fahrenheit to Celsius. After that one, I have temp1, and I also have temp2. Now inside of that global scope, we have a single local scope. Our functions define a new local scope. This scope contains everything created in the code block, so that would include the Celsius variable, but it also includes the function arguments. So in this case, we would have a local scope. This local scope would have Fahrenheit, which is the function argument, and it would have Celsius, something defined in the function itself. This means that we can't access Fahrenheit or Celsius outside of the function even after it runs. So right here, I cannot access Fahrenheit, I cannot access Celsius. They are not in scope. All I can access at this point would be convert Fahrenheit to Celsius, temp1 or temp2. So this is the exact same thing we saw with if statements. The scope tree gets generated in much the same way. We just have a function as opposed to an if statement. And the only difference that you really need to remember is that yes, the arguments of a function are also bound to that local scope, even though they're not defined inside of the curly braces. Now we could add one more thing to this example to make it a bit more real world. Let's say inside of the function, I want to add an if statement. If, and I want to check if Celsius is less than or equal to 0, which is the freezing point in Celsius. If it is less than or equal to 0, I could say let is freezing equal true. Now in this example, what's the scope tree look like? Well, we have a new local scope in our existing local scope. So I'm going to indent local scope. And what do we have in that local scope? We have a single thing is freezing. So for this example, we would have the following scope tree. Inside of this if block, we can access everything because we are either accessing is freezing or we're accessing something from one of the parents. That means I can access Fahrenheit and Celsius. I can access our convert function temp1 and temp2. So functions function much the same way as if statements when it comes to scope in JavaScript. Just because I create something in a function doesn't mean it's accessible outside of a function. And we're going to explore more situations where this actually comes up. For now, you just need to keep this in mind, that functions create a local scope much like if statements do, and function arguments are bound to that newly created local scope. And we got a little tree right here to prove it. All right, that's it for this video. Not a whole lot to discuss. I just wanted to make sure you were aware that functions created a new scope. We're going to continue on and get back to programming in the next one. I'm excited to get to it, so I'll see you then. In this video, I want to take a quick moment to talk about template strings in JavaScript. So we're going to step away from functions for just a second, and we're going to talk about this new way to create strings. Right now, every time we've created a string, we've used single quotes. We put our string characters inside like we do here, here, and here, and then we see that in the result. So in this case, I add all of this stuff up, concatenating them onto each other, and the end result is the message that prints with the user's name and their score inside of this string. Now, what we're going to do is explore the template string. As the name suggests, it's a way to create a template string. So there are parts of this template string that are going to be static, and there are other parts that are going to be dynamic. From a functional standpoint, it's going to do exactly what we already do here, but the syntax is going to make it a lot easier to work with. So let's go ahead and explore this syntax. Down below, console.log, and we're going to make a regular string. The string Andrew using single quotes. This is a regular boring old string. It's something that we've done plenty of times before. I'm not even going to run the program. What I want to talk about though, before I talk about template strings, is that we can create regular strings using double quotes as well. So right here, I can use a double quote and I can type my message inside. There is no difference between the two in JavaScript. I use single quotes because I don't have to hit the shift key, so it's just one less key to press. I also think they look a bit cleaner. You can also use double quotes for all of your strings. That would work as well. I just don't recommend using a combination of the two. Find which one works best for you and stick with it. For me, in this course, I'm always going to use single quotes for my regular strings. I did just want to make you aware that this exists. It's a regular string, and I could even concatenate something onto it. Plus, followed by a single quoted string Mead. So the end result would be Andrew Mead with no space in between. It's perfectly fine to mix the two like this, but as I mentioned, for clarity's sake, I recommend picking one and sticking with it. The only thing we can't do is open and close with a different quote. So I can't open Mead with a single quote and try to close it with a double quote. That's not valid. If I open it with single or double, I have to close it with the same. So these are all just regular strings, nothing new there. I just wanted to make you aware of the double quote syntax. What we're going to explore now is the template string, which is indeed a bit different. To create a template string, we use the backtick key on your keyboard. This is located to the left of the 1 key, and it looks very similar to a single quote, but as you'll notice, it is on a slight angle. And now in here, we can put anything we can put in a regular string. So I can just start typing the characters that I want to use. I could say, hey, my name is, followed by my name, with an exclamation mark. And that's going to print the static string to the screen every single time we run the program. Now let's say we had name above, let name equal Andrew, and we want to use it in the string. Let's go ahead and actually switch the name up to something else. I'll go ahead and use Jen. We want to put it right here, although we want to leave everything before, hey, my name is, and everything after the exclamation mark alone. So what do? Well, with regular strings, we would have to use string concatenation. I would have one string, the first part, then I would add the concatenation operator to tack on name, then I would add on the concatenation operator again to tack on the exclamation mark. For template strings, we just move to the part of the string where we want to inject the value, and we use the following syntax. It's a $, followed by the opening and closing curly brace. Inside, we can add a JavaScript expression. This is where we pick what we want to put in this part of the template string. In this case, we want to put whatever is stored in the name variable. So the end result of the stuff highlighted is going to be the string Jen. The $ and the curly brace do not make it into the final version. This is just the syntax for injecting some sort of value. Let's go ahead and check this out by actually running the arguments file. Over here, node arguments.js. When I run it, what do I get? I get, hey, my name is Jen. If I change the name to something else, hey, my name is Vikram, and I rerun the script, that is exactly what I get. Hey, my name is Vikram, because it's using the new value for the name variable in this particular part of the template string. Now, we could add as many values as we need to into this string. You could say something like, I am 12 years old, or whatever their age is, and this could also come from a variable. So I would add age right here. Let age equal 12. Then I would add the exact same syntax, $, curly braces, inside of there, the thing I want to inject, in this case, age. Now we have a template string with 2 dynamic values inside of it. I can go ahead, rerun it, and I get the full message. So what's the real advantage? And the answer is it's a syntactical advantage. So I can do the exact same thing I do here with regular old strings and the plus operator. The difference is that in my opinion, and in the opinion of a lot of others, this is way harder to read than this down below. This is also way harder to change. So let's say I want to move name to the front of the string, or I want to take this part of the message and move it to the end, putting score in the beginning. I have to rearrange things and also rearrange the plus operators, making sure to remove the leading and trailing spaces around appropriately. It becomes quite a bit of a headache. With template strings, it's really easy to rearrange things. If I want to move the first sentence after the second sentence, I can just go ahead and cut it out. I can remove that one space, I can add a space here, and I can paste it in. So with template strings, it's way easier to actually work with them. Using concatenation, yes, we can get the job done. It's just not as ideal as working with template strings. So since we know a better way to do things, let's go ahead and actually use it. I'm going to replace the string here with a template string. So what are we going to do? I'm going to return, and I'm going to create a template string using the back tick, which automatically gets closed for me. In here, I'm going to put everything I want. So it's name, colon, space. Then we are going to inject the name. So $ curly braces name. Then after name, I'm going to add a space hyphen space, score, colon. Then I'm going to inject at the very end the actual score variable. So this and what I have down below are going to produce the exact same output. I just find this much more readable and way more maintainable. Let's go ahead and prove that it actually still prints the exact same result by saving the file and rerunning things. The last time we ran it, we got this message. If I rerun it again, we get the exact same message. Name anonymous, score 99. Template strings, once again, do not really give us any new functionality. It just gives us a better way to get things done. It's something we're going to be using extensively throughout the course. I'm going to remove the regular string return statement, and down below, I'm also going to delete the example we set up since we now have an example right here. Your challenge for the video is going to be to integrate a template string into the getTip function down below. So let's go ahead and talk about what I'd like you to do. Your job is to return a string, a little message from getTip, as opposed to returning just the actual tip value. And the string you're going to return is going to be created from a template string. So let's go ahead and explore this. Right here, the message for this data would look like the following. A 25% tip on $40, the value passed in, would be, and the actual calculation would be 10. So instead of just returning the number 10, I am including the number 10 in the larger template string. Now there are three values here. We have 25. To calculate this, you just take the tip percent and multiply it by 100. We have 40, which is just passed in directly, and we have 10, which comes from the calculation right here. It's going to be your job to put all of this together inside of a template string. You can create a couple variables beforehand to run those calculations, and then you can return the template string, much like we return a template string up above. Take as much time as you need to get this one done, and then mess around with it. Try to pass in a few different values and make sure you do see the correct message for each. Pause the video, and when you're done, go ahead and click play. All right, how'd that one go? Hopefully you were able to get things done without too much trouble. I'm going to go ahead and kick things off by creating a few variables. First up, let percent equal, and here I'm just going to take the tip percent and I'm going to multiply it by 100. That's going to convert 0.2 over to 20, which I need for this first part. Now for the second part, I don't have to do anything. I have that number passed in directly. For the third part, I do want to calculate the tip. So let tip equal the total times the tip percent. That is going to give me, in the case of this data, a value of 10. And then finally, I'm going to return the template string. So right here, let's go ahead and open and close some back ticks, and we're going to start filling things out. So a space followed by the percent value from up above, $ curly braces, percent. Then after that, space, actually not space, we're going to use the percent sign. Then a space, tip on space, $, and this is where we put the total. So $ curly braces, total. Then after the total, space would be space, and then finally we wrap up with a $, and then the actual calculated tip. So $ curly braces, right inside of here, tip. Now we can actually test things out by rerunning the file. I'm going to save my work, rerun things from the terminal, and I get a 25% tip on $40 would be $10. Everything is working well, and we were able to set up this string using template strings. Now let's go ahead and switch up the values. I'm going to switch to the default 20% tip, and I'm going to switch the number over to 50. If I rerun things this time around, I'd actually still get 10. Let me switch this over to 60 to see a different value print. I rerun it, and I get a 20% tip on $60 would be $12, which is correct. All right, now that we have this in place, I want to show you one alternative way you could have gotten this done. You can actually run these calculations right inside of the curly braces. So if I wanted to, I could calculate tip percent times 100 right here. I could do the exact same thing for the tip. I could multiply the total times the tip percent to get the actual total tip. This would allow us to remove these two variables completely. Now, this is not necessarily what you want to do in all situations. It's just a different way to solve the problem. If I were to save things and rerun things, we get the exact same message. The calculations are still being executed the same, they're just now embedded right in the template string. This can be good in some situations, but it can also create situations where the template string is now much easier to read through since it includes more code and math operations. So I am going to actually undo those changes and bring it back to the example I had before, where I simply reference the percent variable right here and the tip variable right here. This is all about personal preference and style. I prefer to keep my template strings cleaner, just referencing variables, as opposed to trying to run calculations right inside, creating a situation that's just a bit messier. All right, that is it for this one. Now that we know how to use template strings, we can use them throughout the course to create more meaningful messages. I'm excited to continue on. I'll see you next time. This video is going to be the last video for this section, and it's going to be a challenge video. So I'm going to set up a little project for you to build, and you're going to go off and write all the code required to get the job done. Obviously, since we just learned about functions and a lot of their features, this one is going to be focused on just that, but it'll also require you to recall things learned in the last section, primarily if statements. Now, at this point in the course, we're going through these sections of just 6 or 7 videos to get a cursory overview of each feature. There is more to functions than what I've described so far, but it doesn't really make sense to get into super advanced function features when there are other entire parts of the language that we still don't know, things that are really important, notably objects and arrays. So while there are more to functions, and we will be talking about them in that course, this is a great place to stop for now. We'll focus on some other features, and once we have a better overview of the entire language, we'll focus on advanced parts of each. So for the moment, let's go ahead and create a brand new file for this challenge. To clean things up, I'm going to close all of the open files. You're more than welcome to leave them open. The choice is yours. And right here, I'm going to create a file called grade-calc.js. And as the name suggests, it's going to be your job to create a grade calculator function. This grade calculator function, which you'll be creating, is going to take in 2 arguments. It's going to take in the student's score, and it's going to take in the total possible score. So if I have a test worth 20 points and I get a 15 out of that 20, I would pass in 15 for the student's score and a total possible score of 20. And the goal is to generate the letter grade as well as the percentage the student got. So for that example, if I did get a 15 out of 20, that's a 75%. So I would want to print a message along the lines of the following. You got A followed by the letter grade, a 75% would be a C, and then we're going to include in parentheses their percentage. So in this case, that would be a 75%. And we can toss an exclamation mark or some other punctuation on the end. So this is the goal. Given those 2 inputs, generate the percentage, figure out what letter grade that corresponds to, and return a string. So in the end of the day, we're returning a string from the function. Just to jog your memory, here are the following groups: 90 to 100, A, 80 to 89, B, 70 to 79, C, and then for D, we got 60 to 69, and anything under 60, 0 to 59, that is considered an F. It's going to be your job to use the functions, the arguments, the if statements, the return keyword to make all of this possible. Then down below, you're going to go ahead and actually call things. You're going to call the function passing in the student score and the total possible score, and then you're going to print the string to the screen, making sure it looks correct based off of the input you provided. So if I do provide 15 and 20 as the two arguments, I would expect this exact message to print, and then just mess around with a couple of other values. Switch up the student score to fall into all of these ranges and watch all of the different letters show up. Now, I'm not going to give you any more than this. It's going to be up to you to write every single line of code using what you learned. So take some time to knock this one out, test things out, work through your bugs, use the internet or any previous videos if you need to, and when you're done, come back, click play, and we'll move through things together. Take a moment to pause the video. All right, how'd that one go? Hopefully you were able to create it without too much trouble. Step one is to define this function right here, let. You can call it whatever you want to call it. I'm going to call mine grade calc, and then I'm going to set it equal to a function. I'll set up my arguments right here, and I'll set up my function body down below. Now, what arguments do we want? We want two. The first one representing the actual number of points someone got on an exam, and the second one representing the total number of points. So I can call the first one score, and the second one total score or some alternative. Once again, it's not these things that are important to completing the challenge. There are infinite numbers of names that would make sense there as those argument names. Now, inside of the function, what do we want to do? Well, the first thing we're going to do is calculate that percentage. That percentage is going to be calculated the same way regardless of what bracket they fall into. So right here, I can say let percent equal, and I'm going to calculate the percentage, which is the score divided by the total score. And this would give us a decimal. So for 15 and 20, I would get 0.75. If I want to get a percentage like 75, all I have to do is multiply that value by 100. Now we have an actual percentage we can work with, and the next thing we're going to do is figure out what letter grade the percentage corresponds to. And we can get that done with if statements. I'm going to use a series of if and else if clauses to capture all of the various ranges. And I'm going to kick things off with the letter A. So right here, if. And we're going to add if, and we're going to talk about the percentage in this condition. So if the percent is greater than or equal to 90. If this is true, we know the person got an A, so we can go ahead and do what? Well, we can go ahead and return a message. So I'm going to return. I'm going to set up a template string. And then right here, we are going to start injecting those values. So you got, then A, and then inside of parentheses, we are going to add the actual percentage. So right here, how do we inject a value into template strings? Well, as we explored in the last video, $, open and close those curly braces and reference the variable right inside, %. Excellent. Now things should be working for the letter A, and before we continue on, we can actually test it. There's no reason to create the entire function before actually testing things out. Down below, let result equal. I'm going to call grade calc to test my new function, and I will pass in 15 as the score I got and 20 as the total number of points. Then down below, console.log, passing into log the result. Let's go ahead and run this file and make sure we do get our message. Whoops, our message is actually for an A. Let's go ahead and change things. Right here, I'm going to give them an A by saying 19 out of 20 points. Now we can save things and actually run it. Node grade calc.js. When I execute the file, you get an A, 95 showing up. I also meant to add a percentage sign right after the value, so I'm going to toss that in right here. Excellent. Now we can move on to the B grade. Right now, we don't have any code that handles that. So down below, what are we going to do? Well, there are a bunch of different ways we could solve this problem, but the way I'm going to go with is to add an else if clause right here. We're going to provide another condition and another block of code to run if the condition is true. Now, what do we want to do here? We want to see if the grade is in this range. So we want to see if it's greater than or equal to 80 and less than or equal to 89. That means we need to add two conditions. But do we really? We already know that we do not have any A's showing up here, because if the student did get an A, it would have already been caught by the code above. So all we really need to do is check if the percent is greater than or equal to 80. You might say, hey, what about a 99? Well, don't worry about that, because a 99 would have gotten caught above and the code would have returned. This condition would never actually run for a 99, so this is all we need to see if the student got a B. Now, what are we going to do here? Well, what we're going to do in here is return a message, and the message is going to be so similar to the one above. If we copy and paste it down below, all we really do is change a letter. We change A to B. Well, this gets the job done. It's not the most efficient way because we have this string in many different places. So if I wanted to change the sentence, for example, I would have to go through and change every single instance of it. While this is a perfectly fine way to get the job done, I'm going to show you an alternative solution. First off, though, let's go ahead and actually get a B. I'll give myself 17 out of 20 points. I'll rerun things over in the terminal. And right here, I do have you got a B at 85%. Now what we're going to do before we add the other letter grades is restructure things just a little bit. Up above, what we're going to do is create let, and I'm going to call this one let letter grade, and I am going to set it equal to, and we can just start it off as an empty string or undefined or something along those lines. What we're going to do is change the value of letter grade inside of the if code blocks. Then after the if code blocks, we will return a template string. That's going to make sure that we don't have duplicate code inside of our function. So let's see what that would look like. Right here, inside of this if statement, we're going to set letter grade equal to and A. Then we can actually remove the return statement right here. In this code block, we're going to set letter grade equal to B. Then we can remove this return statement right here. I'm actually going to cut it out instead of deleting it completely because we're going to use it just down below. After our if statement, but still inside of the function, we're going to paste that line. Now we are returning the string, and all we have to do is replace the static letter B with the value of letter grade. So right here, $ curly braces. Whoops, there we go, $ curly braces. And inside of there, we reference the letter grade variable. So hopefully you're able to see why this is preferred. Instead of having this sentence in all sorts of different places, we have it in just one, making it much easier to update and maintain. Now we can continue on with our if statement, else if. We're going to check if the percent is greater than or equal to 70, and if it is, we know the student has a C, so letter grade equals C. Next up, else if. Let's go ahead and figure out if they got a D. If the percent is greater than or equal to 60, then we know they got a D. Right here, letter grade equals D. And the final thing we're going to check is if they got an F. Now we could use an else if to see if their grade was above 0, but if they didn't get an A, B, C, or D, we know they got an F. So we could actually just use else. This code is only ever going to run if they do not fall in any of the other ranges. So in here, letter grade equals F, just like this. Now that we have the if statements in place, we can actually test things out. I'm going to switch it up from a 17 to a 15. This should give the student a C. Let's go ahead and save the file and rerun things. We got our file right here. I rerun it and I see you got a C, 75% printing. So our new system of setting letter grade up above and just returning a single template string down below is clearly working. Let's switch up the grade again. I'm going to go to a 13, which should give them a D. And you can see right here, you got a D at 65%. And then I'll switch things up to a 9, which should be an F. I'll rerun it. You got an F at 45%. So this is what I wanted you to do for the challenge. As I've mentioned plenty of times before, the individual details aren't important. You might find that your code doesn't look just like mine. If I were to write this 5 times, I'm sure I could come up with a different solution each time without even really thinking about it. What is important though is that given the inputs, you got the correct output. In order to get the correct output, you would have had to use things like if statements and function arguments and template strings. Maybe you didn't use template strings, maybe you used regular strings with concatenation, that's fine too, but in that case I do challenge you to take a quick moment to upgrade to use template strings, as they are a lot nicer to work with. All right, that's going to be it for this challenge, and that's also it for this section. We have a basic understanding of how functions work in JavaScript. What we're going to do is move on to the next section and take a look at a couple of other types that are essential to working with JavaScript in the real world. I'm very excited to get to that, so let's go ahead and jump right in to the section intro for that one.